So here is our question number 22 that is available in section C. So it's the first question of section C and it is written, identify the circuit element X and Y as shown in the given block diagram. Okay, and the diagram is shown in the figure, and output waveform, and draw the output waveforms of X and Y. Okay, so first we have to identify. So in this picture, element X helps to convert, this is your AC input, this is called AC input, and here DC appliance is attached. That means this is your rectifier. And which type of rectifier? This is your full wave rectifier. So element X, so regarding element X, we have to, what we have to write? So we have to write element X, this helps to convert, this helps to convert AC to DC, and finally due to element X, DC appliance is used. Okay, so it is a rectifier. Finished. And which type of rectifier? This is your full wave rectifier. Okay, and next come to element Y. Element Y. So as it is used, now see the diagram, element Y is used before the DC appliance. So as it is used before DC appliance, so it is your filter circuit. So it is filter circuit. Okay, so this is our answer. Element Y is filter circuit and element X is full wave rectifier. Again it is written, it is asking draw the output waveforms of X and Y. Okay, we have to draw output waveforms of X and Y. So element X output wave, this is your full wave rectifier. So the output waveforms will be like this. This is our output waveforms. Okay, this is V out and this is time t in case of X, element X. And output waveforms of Y, this is your rectifier, this is your filter circuit. Element Y is filter circuit. So filter circuit means, what is its role? It converts pulsating DC to pure DC. Okay, so the output here in Y axis, you have to mention output with capacitor, and this is your time axis, and the diagram is like this. Okay, so this is about your bit 22, question number 22, bit I. Then in second bit, it is given, if the center tapping is shifted towards diode D1 as shown in the figure, this is your diode D1, this is diode D2, and this is your center tap. If it is shifted towards D1, draw the output waveforms of the given circuit. Now see the figure properly. These are the number of turns available in your secondary coil. Okay, so if the center tap shifted towards D1, what will happen? Then on shifting the center tap towards D1, number of turns towards D1 is how much? Number of turns towards D1 is suppose 2 as per the figure, and the number of turns towards D2 will be 4 somehow. That means number of turns towards D1 is less than number of turns towards D2. Okay, are you getting my point? So you have to write the concept actually. First you have to mention the theoretical part. So in second bit, we came to know on shifting on shifting the center tap towards D1, we will get number of turns towards D1 D1 is less than number of turns towards D2, and we know number of turns is proportional to EMF induced. So EMF developed, EMF on D1 is less than EMF on D2. Yes, so because of this reason, what we have to draw the output waveform of the given circuit. So now, in case this is your full wave rectifier diagram, so in case of the waveform diagram, what you will get? Now see, this is your output waveform, that is your across RL, and this is your time t. Yes, so EMF developed on D1 is less. Because of this, you have to draw the diagram like this. This is due to diode D1, and EMF on D2, that is more. This is the EMF on D2. Then EMF due to D1 and EMF due to D2. I hope you all are getting my point. Okay, as the center tap shifts towards the D1, so number of turns towards D1 is less than number of turns towards D2. So EMF developed on D1 is less than EMF developed on D2. So this graph represents this thing. So it is due to, you can mention due to D1, and second one is due to D2. Then due to D1, then it is due to D2. And you remember, if the center tap attached at the middle, suppose this is the secondary coil and center tap is attached to the middle part. That means EMF on D1 is equals to EMF on D2. So earlier we have drawn the graph like this. In case of full wave rectifier, the graph is like this. That means center tap is at the middle portion. Okay, this is the significance. And next in the same question, another question is there for VI candidate. Which device, it is mentioned, which device is used to convert AC into DC? Okay, and it is asking state its underlying principle and explain its working. So first thing, the device used to convert AC to DC. First you have to write. So device used to convert AC to DC, that device is called your rectifier. Its name is rectifier. Okay, and what is its principle? As it converts AC to DC, so it transforms the current. Okay, so in principle you have to write transformation of current by changing the frequency of input signal. Transformation of current by changing the frequency of input signal. I hope it is very clear to all of you. So as it converts AC to DC, so it transforms the current by changing the frequency signal. Okay, so what is its working of rectifier? Now see, in rectifier, in case of rectifier, one end of terminal which is connected to PN junction diode will never have negative potential. Because in case of half wave rectifier, it may be 0 or not equal to 0, and in case of full wave rectifier, it is always not equal to 0. That is having some positive potential. It never have negative potential. Okay. That means potential across load resistor will always be positive or 0. Always you remember those potential across load resistor will always be positive or 0. Okay, so my instruction is to all of you is please go through the half wave and full wave rectifier in detail, okay, which you have already covered during this academic session, so that it will be very easier for you all. Okay, and next it is mentioned if the frequency of input AC to this device is 60 Hz, then what will be the frequency of output of this device? And here the device is not mentioned properly. Okay, which device is convert AC to DC? It may be half wave rectifier and full wave rectifier. So you have to write the answer for both the cases. So frequency input is given 60 Hz. So it is mentioned given frequency input is equals to 60 Hz. And always you remember, in case of half wave rectifier, frequency output is equals to frequency input, that is equals to 60 Hz. And in case of full wave rectifier, frequency output is equals to 2 times of frequency input, that is 2 into 60, that is your 120 Hz. Okay, and if in the question it is mentioned about your time period, remember time period of input output, that is your same, but output time period is half of the input time period in case of full wave rectifier. Please note it down. Okay, input time period equal to output time period is in case of half wave rectifier, but output time period is half of the input time period in case of full wave rectifier. Okay, so I hope it is clear to all of you. So this is about your question number 22. Now you can take the screenshot. This is your element X and Y, and this is the waveform. This is the second part, and what will happen to the diagram with region I have already explained. Okay, next is the question related to VI candidate. Yes, you can take the screenshot. Okay, thank you, have a nice day.